The solid urban waste disposal is a main problem both from the social and economic aspect. Daily amounts of 3,000 tons are very common in large European cities. The sanitary landfill management is very critical also from an environmental point of view. Efforts can be made for avoiding soil and water pollution, but it's quite impossible to eliminate the unsafe effects on the surrounding inhabitants and particularly on the operators driving the vehicles inside the landfill. In October 1992, inside the Esprit 3 framework, the project EP6068 Athena, Advanced Teleoperation for Earthwork Equipment Navigation, started with the aim of the operating semi-autonomously a compactor inside a sanitary landfill. A research consortium led by Technopolis has been built in order to carry out the project activities. The team embraces 10 partners belonging to the 6 different states of the European Union. The whole Athena control system can be roughly categorized in 2 parts connected through an high-speed radio link. The onboard system that is in charge of the real-time control of the vehicle, and the off-board part that supports the human operator in the supervision and the telecontrol of the vehicle. The off-board part of the Athena system is functionally composed of a man-machine interface that provides the operator with adequate devices for the input of commands and for the data visualization, and a surveillance system that, by means of cameras placed around the working area, is in charge of detecting any intruder entering the work site. The onboard system is more complex, being the interface between the commands coming from the man-machine interface and the vehicle sensors and actuators. The software needed to make this interface is structured in the following specialized modules. The vehicle controller that is in charge of the low-level control of the vehicle, as well as of the maneuvering of the onboard video camera. The risk manager that is in charge of detecting risk condition and implementing some low-level reflexive behaviors. The position determination system that provides the vehicle position and speed by means of an advanced laser-based sensor. The environment modeling that builds and maintains an updated model of the working area. The path planner, whose task is to find the optimal trajectory according to the requested movement and avoiding any known obstacle. An analog radio remote console is also present in the system architecture as an independent auxiliary control system, able to take the control of the vehicle at any moment in case of fault of the radio link or of some modules of the digital control system. This analog console guarantees a reliable basic teleoperation mode for the vehicle by means of a joystick-based command console that drives through a dedicated radio link electro-hydraulic servos installed on the vehicle actuators. Moreover, the operator through the analogic console is able to pass the control to the digital system. Inside the Athena project, the advanced teleoperation system architecture has been designed having in mind an incremental implementation referring to a progression of levels of autonomy to be reached by the vehicle. It means that the vehicle autonomy has been thought to grow during the project lifetime. The first level, basic teleoperation, features a pure manual teleoperation. This consists in controlling the basic driving devices of the vehicle: throttle and brake pedals, blade lever, steering wheel, gear stick, through a radio remote console provided with joysticks and buttons. The second level, risk detection, features basic safety reactions of the vehicle upon detection of risky situations. It means that some sensors are required in order to detect the risk locations, but the control will just stop the vehicle. The automated teleoperation levels aim to provide more comfort to the operator by allowing high-level guidance of the vehicle. At the same time, more autonomy in the vehicle's operation will add the capability to avoid the detected risks rather than react with a simple reflex action or to execute pre-recorded sequences of motions. An experimental site has been arranged for the integration and test phases of the project, simulating the morphological characteristics of a sanitary landfill for urban solid wastes. The site occupies a rectangular area of 50 by 70 meters and is enclosed by an embankment that also upholds the control room. Plinth complete of anchoring bolts for the positioning of the reflectors and video cameras have been installed all around the simulated sanitary landfill. The final system has been demonstrated to the reviewers of the European Commission DG3 in June 1996. The implemented advanced guidance modes demonstrate the suitability of the computer-aided teleoperation techniques in order to avoid the direct presence of a human on the vehicle in such hazardous conditions. The system developed in the Athena project allows to operate the compactor sitting in a comfortable control room. The automated teleoperation level aims to provide more support to the operator by allowing high-level guidance of the vehicle through a camera drive mode, that means the designation of vehicle geometrical goals by pointing the onboard camera, or a go-to-goal mode in which the target point is simply chosen in a top-view map. At the highest level of autonomy, the recording, editing, and execution of predefined sequences of motions, called macros, is implemented. Besides, more intelligence in the vehicle autonomy allows to avoid the detected risks rather than react with a simple reflex action. The Athena results demonstrate that in several fields involving earth-moving machines, to release the human operator from an hazardous working condition is now a real chance.